So today we are going to talk about chapter number 6, that is Fourier series and Fourier transform. Okay, and these are the content of this chapter. We will see Fourier series, Fourier transform, and properties, or we will see one by one. Now, before going to all these slides, first I want to give you some basic idea of this chapter. Okay, so this is chapter number 6, Fourier series and Fourier transform. Okay, so these two are the methods, Fourier series and Fourier transform. These are something like tools or methods, you can say. First thing, uh, this Fourier is the name of Ali. Complete name Joseph Fourier. Okay, and around 150 years back, around 150 years back, he gave these formulas. Okay, these methods, you can say. What is this? Now listen very carefully. Let's suppose I have a signal like this. Okay, this signal is ft. The name of this signal is ft. It start from okay. Now every signal is a combination of sine signal or cosine signal, cos signal, you can say, or third one, mixture of sine and cosine. So every signal, even my I'm speaking, my speech, my voice is a mixture of either sine or it can be a sine signal, it can be a cos signal, it can be sine plus cos signal. Every signal, this is square signal. What is this? Is the mixture of maybe sine or this signal is a mixture of many sine signals or many cosine signals or a mixture of many sine and cosine. So this concept was given by Joseph Fourier. Now see, first of all, we will see the equation later on, but for the division point of view, I want to tell you something how to write the equation. You must know how to write the equation. This is sine signal. Okay, what is the equation of how to write the equation of this signal? Let's suppose amplitude is b, so you know how to write amplitude, then we write shape, then we write x-axis. We have seen this one in chapter number 2, but for the quick revision I am writing. So amplitude is b, shape is sine, x-axis, now we are taking omega t. X-axis is omega t. Okay, frequency, and this is x-axis. Now let's suppose this is signal 1. So amplitude of this signal is b1, and the frequency of this signal is omega multiply 1 multiply t. Okay, I have one more signal. Let's suppose this one, yellow signal. So what is the equation of this yellow signal? Amplitude, let's suppose b2 now. Amplitude is b2 sine omega 2t. I have one more signal, this red signal. Now what will be the equation for? Let's suppose b3 is the amplitude, then sine, then omega 3t. If I have 1000 signal, now it is very difficult to write down the equation for each. So what we do the summation. Summation means majmua, add all the signals. So this is the amplitude variable, this is the shape, and this is omega, and I am writing n. And how many signal? Let's suppose I have 1000. So if I put 1, so it will be v1 sine omega 1t. Okay, if I write 100, so it will be b100 sine n sine omega 100t. So this equation is a general equation. It's a general equation for many sine signals. If you have many sine signals, okay. If I don't have any limit, then we write here infinity. Maybe signal, maybe so many, okay. And same equation we write for the cos. What is cos signal? What is cos signal? Cos signal looks like this, okay. What is the equation for cos? So a is variable, then cos, and then omega t. This is the equation. Same here, if I have one million cos signal, so how to write? N is equal to 1 to 1 million, then variable a n cos omega nt. So we write here 1 million, or you can write infinity. Okay, so this is this shows majmua of, or a combination of many sine signal, and this shows a majmua of many cos signals. Okay, remember these two equations. Now what I told you this signal is maybe mixture of mukhtalif different sine waves, or this signal may be the mixture of mukhtalif cos wave, or this signal may be the combination of mukhtalif sine plus cos signal. So I know from here I know the equation of sine, mukhtalif sine signal, and I know the mukhtalif cosine signal. So in the Fourier series, what is Fourier series? Now what is Fourier series tells? Ft is equal to a naught. I will tell you in this folder what is a naught. Then summation n1 to infinity. Fourier series tells there in a signal there may be many sine signals or cosine signals. So a1 a1 to infinity, then a n cos n omega t, or omega nt for this omega, same meaning, both has same meaning. Then n1 to infinity, bn sine bn sine omega nt. So any signal, this signal can be the mixture of mukhtalif cos signal, mukhtalif sine signal, or mixture of both. What is A naught? A naught is called DC level of the signal. DC level of the signal. Okay, it is called DC level of the signal. It is something like, you can say, where is the location of x-axis? Where is the location of x-axis? This is called DC level. Now, these are, if you notice, A naught is a variable, An is a variable, Bn is a variable, cos is a standard one, omega is what? Angular frequency, 2 pi divided by t. You have studied in chapter number 2, angular. N is a number. So A naught, An, and Bn, these are the unknown variables. I have to find out these variable value. Now, what is A naught? A naught is 2 divided by t, t naught, t naught plus t, ft dt. Very easy. Listen to me very carefully. What is this t? This is time period. Time period. If we remember in chapter number 2, we have seen this time period. Let's suppose this signal start from 0, and this is one cycle. And after this point, second cycle. So how much is the time taken by one cycle? This is called t. So this is, let's suppose, 0 to pi. It is going 0 to pi. So time period will be 2 pi. What is this? This is the starting point of the cycle. starting point of the cycle. Now this is the cycle. What is the starting point of this cycle? 0. So t is 0 is 0. And this is end point of the cycle. This is called end point of the cycle. What is end point? 2 pi. So end point is 2 pi. This is the value of a naught variable. And what about an and bn? What about the variable an and bn? It is also very easy. Now see, an is equal to, just copy a naught here. 2 divided by t. This is t naught plus t ft, and stop here. Now with an, cos is there, so write here cos and or omega n, no problem, and dt. Okay, I am writing the same as I have told you before, omega n t. Okay, this is an, and in the same way, what is bn? 2 divided by t naught plus t ft. With bn, sign is there, so you have to write sign. Okay, this is multiply. So these variables a naught, an, and bn, this complete thing, this complete one, you can say this is Fourier series. These are the variables of Fourier series a naught, an, and bn, and this is Fourier series. Okay. Now come to the slides. One more point here I want to tell you, yes, about Fourier series and Fourier transform. Fourier series is used for periodic signal. Periodic signal means like this. When the signal repeats itself, periodic signal, in chapter number 2 you have studied this periodic signal, type of signal, periodic signal. When there is the cycle, this is first cycle, second cycle, third cycle, third, second, and this is first cycle. For periodic signal, we use Fourier series. If I to know how many sine or cosine signals, or sine and cosine signal both are present, then we use Fourier series for the periodic signal. Fourier transform is used for aperiodic signal. Aperiodic signal, when the signal doesn't repeat itself like this, like this. This is aperiodic signal. Aperiodic signal or non-periodic. Non-periodic signal. Okay, so this was the important point, and it is all written over here. Periodic signal Fourier series, periodic non-periodic signal Fourier transform. This is analog, and for the discrete, we use different technology that is not in your course. Okay, what I have told you, it is all written here. A naught, A and B, and okay, this is DC part. This is even okay. Just you have to focus the equation. This is DC part. This is important. DC part. And this example I will tell you in next video. Thank you.